Hey guys, this is Professor Janacek, and I want to discuss antiderivatives. Let's first begin by reviewing what a derivative is. So, if you recall from the definition of a derivative, we begin by letting f be a function. The derivative of f is denoted f prime of x, and it is the limit as h approaches 0 of f of x plus h minus f of x divided by h. It could also be written as the limit as x approaches a of f of x minus f of a over x minus a. Now let's take a look at an antiderivative. We're trying to undo that derivative process. Again, let's let f be a function. The antiderivative of lowercase f is any function uppercase f such that the derivative of uppercase f of x is equal to lowercase f of x. The most general antiderivative of lowercase f is called the indefinite integral, and it is denoted using the stretched out s followed by f of lowercase f of x dx. And this is equal to uppercase f of x plus c, for c a constant. Now just so you know, this stretched out s, and it does indeed come from the letter s, is the integral symbol. The function f of x is called the integrand, and dx is the differential. Specifically the differential on x. Now, that variable x is referred to as the variable of integration, and c is called the constant of integration. Let's take a look at some examples. Example 1, we have f of x is equal to 3x squared. Now what we're looking for is a function that when we take its derivative, we get 3x squared. Well, it turns out that if I take the function x cubed plus a constant, and that could be any constant, when we take its derivative, we end up with 3x squared plus 0, which, by the way, is lowercase f of x. So again, the idea is I'm trying to find a function. When I take its derivative, I come up with my original function. So if I take the derivative of x cubed plus c, we end up with 3x squared. Let's take a look at the next example. For f of x equal to 1 over 1 plus x squared. Well, if you recall, the inverse tangent of x has a derivative that is 1 over 1 plus x squared. So taking the derivative of the inverse tangent of x gives us our original function. Let's take a look at one more example. F of x is equal to the sine of x. So what can I take the derivative of that gives us the sine of x? Well, I do know that it's going to be connected to the cosine function. So notice that if I let uppercase f of x equal to negative cosine of x plus c, when I take the derivative of this, well, that's going to be a negative times the derivative of cosine, which is negative sine of x, plus the derivative of a constant, which is 0, which is simply the sine of x, which is our function lowercase f of x, which is where we started. So again, this is kind of a game where I try to figure out what can I take the derivative of that gives me my given function. I do also want you to notice something here, that since the derivative of any constant is equal to 0, then the antiderivative of any function f, which by the way is equal to f plus 0, must have the form of uppercase f, that's the antiderivative of lowercase f, plus a constant. And remember, the antiderivative of 0, is a constant based on this. So you'll notice that every time we come up with an antiderivative, we always have to add this constant. Now, we don't know which constant this is. It could be any value, so we often refer to it as an arbitrary constant. Also, I want to make a note about notation. So if we take the derivative, if we write the notation d dx of f of x, this means to take the derivative of f with respect to x. Notice our variable is x. Similarly, if we integrate or find the antiderivative of f of x dx, notice I'm using dx in both situations, this tells us to find the antiderivative of f, again with respect to x. So our differential there, dx, is kind of indicating the variable with which we work with. Now we do have a few properties dealing with these antiderivatives or integrals. If we have the integral of a constant times a function, turns out it's the same thing as the constant times the integral of the function. If we have the integral of a sum or a difference of two functions, turns out that's the sum or difference of the integral of the two functions. Now we'll get to have lots of fun with these antiderivatives or integrals. For now, enjoy!